We thought we understood the universe. For decades, humanity looked to the stars with growing confidence, believing that our models and mathematics were closing in on the ultimate truths of existence. We thought that the expansion of space was a settled matter, a question long resolved by observation, consensus, and scientific rigor. We believed that with each telescope launched and each equation verified, we were peeling back the layers of cosmic mystery to reveal a coherent, elegant truth beneath it all. But we were wrong. Profoundly, astonishingly wrong. The James Webb Space Telescope, working in tandem with the legendary Hubble Space Telescope, has just delivered what could be the most unsettling and transformative discovery in the history of modern astronomy, a revelation so jarring that it threatens to shake the very foundation of how we define the universe. The universe, it turns out, does not behave the way we believed. Not even close. Decades of carefully crafted cosmological theory, once thought to be solid pillars of understanding, are beginning to fracture under the weight of new data. Measurements that had long aligned across multiple models are now in sharp and irreconcilable contradiction. And what's more terrifying is the emerging implication that something, perhaps a force, perhaps a phenomenon, exists beyond the known boundaries of the observable universe, something that may be influencing or even altering the laws of physics themselves. This is no longer just a crisis in abstract theory. It is a full-blown collapse of our deepest assumptions about space, time, matter, and perhaps even reality itself. It began with a bold idea, born from the desire to see deeper and clearer than ever before. By combining the near-infrared capabilities of the James Webb Space Telescope with the time-tested visible light precision of Hubble, astronomers hope to construct a more complete picture of the cosmos, a composite image of the early universe so detailed and rich it would reveal the story of cosmic evolution itself. The goal was noble, the plan methodical, and the tools were state-of-the-art. But what they found wasn't an elegant origin story. It was chaos. It was contradiction. It was the cosmos defying explanation. Among the first anomalies was a galaxy known as ZF, GS 7329. This structure was so massive, and its formation dated so early in the universe's history, that it shouldn't exist. According to the current models of cosmology, the infant universe simply did not contain enough matter, nor had enough time elapsed for such a large and mature galaxy to form. Its mere presence is a direct affront to everything we believed about the early universe. And that wasn't a fluke. It was the first of many. Soon, more galaxies were discovered, too vast, too structured, too old to fit into the Big Bang-based timeline. Black holes were observed whose masses defied logic, appearing billions of years too early to have grown so enormous by known mechanisms of accretion or stellar collapse. Then came the most staggering data point of all, the realization that the universe's expansion rate is not uniform. It varies depending on where you look. For years, scientists used a value known as the Hubble constant to measure the rate at which the universe is expanding. It was once thought to be a universal constant, a reliable cosmic speedometer. But the data now says otherwise. James Webb and Hubble, through direct observation of Cepheid variable stars, those reliable pulsating beacons used to measure cosmic distances and distant galactic structures, are producing results that are not merely different, but fundamentally incompatible. The discrepancy is not a statistical error. It is a chasm, wide and dark, tearing through the heart of our cosmological model. Nobel Prize-winning physicist Adam Rees, one of the foremost authorities on cosmic expansion, summed up the gravity of the situation when he said, if measurement errors are ruled out, the only explanation left is that we fundamentally misunderstood the universe. That's not an exaggeration. It's a reckoning. It's the realization that our cosmology, based on the Big Bang, the expansion of space, and the constancy of physical laws, may not just be incomplete. It may be wrong. While the scientific world tried to grapple with the implications, astrophysicist Rajendra Gupta introduced a theory that deepened the crisis and perhaps offered a path forward. He proposed that the universe is not 13.7 billion years old, as widely believed, but nearly twice that age, close to 27 billion years. At the core of Gupta's theory is a radical rethinking of how we perceive light and time. He argues that light, as it travels across the vacuum of space, does more than stretch, it loses information in ways we haven't accounted for. According to his model, what we've been interpreting as signs of dark matter and dark energy may in fact be misinterpretations, ghosts in the machine, artifacts of a flawed lens through which we've been viewing the cosmos. If Gupta is correct, then the implications are staggering. It means that dark matter and dark energy, the invisible scaffolding on which we've built our entire model of the universe, might not exist at all. These mysterious forces, once thought to make up 95% of the total mass-energy content of the universe, could be illusions, mathematical placeholders that vanish when the true nature of space is understood. This would not just require adjustments to our theories. It would demand a rewriting of the laws themselves, from Einstein's general relativity to the complex frameworks of quantum field theory. It would be nothing less than a scientific revolution. Other researchers have gone even further, suggesting that what we're observing might not be caused by flaws in our models, but by influences from beyond our universe. According to this idea, the irregular expansion of space could be the result of gravitational forces exerted by a neighboring universe, one that exists just beyond the limits of what we can see. This multiverse hypothesis, once relegated to science fiction and theoretical speculation, now finds unexpected support in the mathematical patterns and strange inconsistencies revealed by Webb and Hubble. If this is true, then the universe is not an isolated bubble expanding into nothingness. It is part of a larger, interconnected fabric of realities, each influencing the other in ways we're only beginning to detect. For decades, dark energy was the elegant bandage scientists used to explain why galaxies were accelerating away from one another. It was a mystery, yes, but a convenient one. Now Webb's data is tearing that theory apart. If expansion rate differs across regions of the cosmos, and if galaxies form much faster and earlier than predicted, then dark energy doesn't explain the data. It contradicts it. And if dark energy fails, then 70% of our known universe vanishes in a puff of theoretical smoke. That's not a minor adjustment. That's a full-scale identity crisis for cosmology. Despite the groundbreaking implications, institutions like NASA, ESA, and international cosmological bodies have been surprisingly quiet. There have been no official statements acknowledging a crisis, no public retractions of existing models like Lambda CDM. Instead, there are only cautious, carefully worded bulletins mentioning unexpected complexity and early surprises. Behind the scenes, however, reports have emerged of urgent, closed-door meetings between top physicists and cosmologists. A leaked internal memo from one such group allegedly referred to the current state of affairs as a paradigm destabilization point, a term that suggests the very framework of our understanding is under threat, and that public disclosure is being weighed against the risk of widespread intellectual and philosophical upheaval. The implications are not limited to physics. They stretch into every field of human thought, philosophy, metaphysics, theology, even geopolitics. Because if the universe no longer behaves according to the laws we built our understanding upon, then the trust we place in human perception, logic, and scientific reasoning must be re-examined. The very idea of progress, the notion that we are marching steadily toward truth, might be a comforting illusion. Some physicists now suggest that the contradictions we're seeing aren't about space at all, they're about time. One emerging model posits that time may not flow uniformly across the cosmos. In certain regions, depending on the density of matter, the vacuum's energy fluctuations, or even interactions with alternate dimensions, time could be moving faster, slower, or in entirely different patterns than our local frame of reference. This could explain why some distant galaxies appear inexplicably old. They may be existing under a different temporal framework, governed by a clock we cannot yet read. If this is true, then time is not the universal constant we believed it to be. The Big Bang itself may not have been a singular event, but a ripple in a larger temporal ocean, and we are just one wave in an unfolding, multidimensional storm. There is one more theory, rarely discussed in public, but gaining traction among elite theoretical physicists. It's called the cosmic phase transition model. According to this idea, the universe can undergo fundamental shifts in the nature of its physical laws, similar to how water freezes into ice or evaporates into steam. The strange and inconsistent data coming from Webb and Hubble may not be glitches. They may be the earliest signs that our universe is approaching one of these shifts. A cosmic phase transition. If this occurs, it could rewire reality in an instant. The very fabric of space-time could change. Gravity might behave differently. The speed of light might shift. Even the flow of time could reverse or fragment. The laws we thought were immutable would dissolve and reform. Nothing, absolutely nothing, would remain the same. For over 100 years, we believed we were unraveling the universe's mysteries. We measured its expansion, traced its birth, and tried to write its laws into the immutable language of physics. But what the James Webb Space Telescope is now showing us is something far deeper and more humbling. We were never uncovering the full truth. We were only ever seeing what the universe allowed us to see. Those illusions are now dissolving. The constants we trusted are breaking. The structure we mapped may be crumbling. Time may not be a river, it may be a sea, full of hidden currents and unknown depths. And the space between galaxies? It may not be empty at all, but filled with something alive, intelligent, or entirely beyond comprehension. What we call dark energy may be nothing. What we thought was background radiation may be a signal. And expansion we assumed to be a cosmic coincidence may, in fact, be the fingerprint of a force we haven't dared to name. We are no longer just asking how the universe began. We are asking if it's still beginning, or worse, if it's preparing to end. Let us know your thoughts in the comments. Are we witnessing the unraveling of cosmic order? Or the first hints of a transformation the universe has experienced before and will undergo again? Subscribe and turn on notifications, because if reality is rewriting itself, then what we are seeing may be the first line of a brand new chapter or the last page of the one we've always known.